Okay, so first let's focus on the translation movement of a rigid body. And first let's look at how we define the position of a rigid body that is moving with translation motion. So consider a rigid body. Okay, let's say we have a rigid body here, and you have 2 points, points A and points B. Let's say we define the position of point A and point B. So this is A and this is B. We define its position using a position vector. And of course, if you want to have vector, you have to have your fixed reference frame, right? So let's say we put our reference frame here. Okay, so y and x, and then our position. So our position vector will be something like this, right? Okay, so a vector here and another vector here. So you have RA for position vector for point A and RB for position vector for point B. So this is what we call a fixed coordinate lah, or your fixed coordinate system. But of course, because this thing is moving and you have more than 1 point on it, you can also have a coordinate system that is moving with the rigid body. So this is what we call a translating coordinate system. So let's say our coordinate system. Let's say we put the frame for the translating coordinate system with the origin at point A. So this frame will be moving together with the rigid body lah. And using that translating coordinate system, you can define the relative position of point B compared to point A using another vector, right? Another position vector. So let's say we define it from here to here. So this is what we call vector RB relative to A. So or R of B with respect to A. And we define this actually by using this equation. So the vector position of RB is equal to vector position of RA plus another position vector from A to B. So R of B with respect to A. Well, this is just vectors lah. For example, you have one vector here, and then you have two vector here. So it's the same thing, right? If you add these two vectors, you will have equal to this vector. So this is what we are doing here. Okay, so this is regarding the position. Then what if we want to measure the velocity and acceleration? So if we imagine your rigid body is actually moving with translation, so no rotation yet. Okay, only translation. It is moving. So what will be the value of RA and RB? It will change, right? Maybe if the rigid body is here, the value of RA is like this, RB is here. But if the rigid body is here, the vector position of RA and RB, of course, will become longer. The vector will become longer. So if we want to measure the velocity of this movement of RB and RA, what do you need to do? Well, of course, we can take the derivative of this equation with respect to time. So what will happen if you take the derivative? You will get drb over dt is equal to dra dt plus drb a over dt. So drb dt is the velocity of B. dRA dt is equal to the velocity of point A. Now, if this object is moving with a translation movement, will this distance, this vector, change if this rigid body is moving? Because this is internal, right? These 2 points are on a rigid body, so distance between these two should not change even if the time changes, right? So this is actually a constant. So if you want to find the derivative of a constant, what will you get? So you should get 0 lah. It means for a translation movement of a rigid body on a plane, the velocity of any point on the rigid body will be equal to another point on it, which is logical because this thing is moving. If point B is moving, for example, at 5 meter per second over here, of course A will also be moving at 5 meter per second over here, right? Because this is a rigid body. If the velocity is not the same, it means this is not a rigid body lah. Maybe it's a slime, it can stretch, or something else happens lah. It's not moving at a translational motion lah. And well, if you follow through, if you want to find the acceleration, you take the time derivative again for VBVA, you will get AB is equal to AA. So similar to velocity, acceleration of B, for example, 1 meter per second square, A should have the same acceleration 1 meter per second square if it's a rigid body and it is moving on a translation. So quite simple. As a summary, all points on a rigid body moving in a rectilinear or curvilinear translation will have the same velocity and acceleration, meaning you can treat this as a particle. You can just pick any particle on the rigid body and then you use what you learn in chapter 2 lah, the kinematics. Okay, all your equations there you can apply if the rigid body is only moving on a rectilinear or curvilinear translation.